Okay, well, let's look. I think this is going to be part 3, okay, of our notes. First thing is, before I go any further, I want to go ahead and at the top of the notes, just for myself, as we reference through it, I can make sure I continuously see that the quiz for this unit is going to be, let's look. I'm looking at our calendar. Looks like it's going to be on 9/18. And the test for this unit is going to be on 9/22. Okay, just so that way you'll have those are important dates, right? We can't be missing test and quiz dates because those are, you can't be missing any dates, but that's really important. Let's go ahead and keep going. Let me turn to where we left off at. I think we left off in physical changes, right? Yes, we were going to practice this. You were going to practice this. We'll see each other again on Tuesday, and we'll go over this then. Here on this side, we've got, we filled it out over physical changes. Now, we're still continuing physical changes. So this is still physical changes, okay? So let's go ahead and get started. And so here, this is just a picture of, phase changes. I know you know what phase changes are. There we go. And this picture here represents liquid. This picture represents a solid, and this one represents a gas. Now, the arrows here on the phase changes, whenever we go from a solid, right, to a liquid, like ice cube, and that's going to melt, we call that melting. So let me get my pen, and we call this. All right, now from here to here, we are going to do what with our energy? Let's think about that. Are we going to take energy in, or are we going to release energy out? So kind of keep that in the back of your mind, because that's super important. Here, yes, they all got energy, but now it goes from one little spot of moving and vibrating to all over, right? You're having to heat it up so it can melt, so it can turn into a liquid. Now, from the liquid to the gas, we call that evaporation. And then from the gas to a solid, which is possible, we call that deposition. And if we want to go the other way, which is completely possible, we can do that as well. We can go from, starting off with the liquid, from the liquid to the solid, we call that freezing. Let's see if we can look at, it's kind of hard to see that color. Let me go get a different color. And when we go from a solid to a gas, we call that sublimation. And when we go from a gas to a liquid, we call that condensation. There we go. So here are our pictures when it comes to phase changes, and yes, there will be some pictures when it comes to like the quiz or the test. All right, knowing that solids, those atoms are close together. Liquids, they're close, but they do have a little bit of space, and a gas takes up the space of the container, so they're far apart from each other. Now let's go ahead and get into the next part, which is chemical changes. So chemical change, or a reaction change, changes the identity of the substance, which makes something new. That's what happens here. the identity of the substance. It changes the identity of that substance, and it just makes something completely new. Okay, now some indicators that a chemical reaction is occurring. All right, well, let's look at that. Some of our indicators. We've got gas production, right? Bubbles, that's how I know. A solid, so if gas bubbles are produced, a solid is produced. We call that precipitation. If there's a change in the temperature because it got hot or cold, that's an indication that a chemical change is occurring. If it releases or puts light off, like firecrackers, right? Fireworks, then that's an indication that a chemical change is occurring. If there is a change in color, like when you dye your hair, right? When you bleach something, there's a chemical change that's occurring. Or if you smell an odor, right? Like something's rotting, that's a chemical change that's occurring. All right, so we've got a little bit of practice here. I would like for you to look over and practice it. We will go over the practice ones here when we see each other on Tuesday, okay? When we see each other on Tuesday, we will do that. Now let's keep going to the next part. Energy changes. Energy and changes. Now, conservation of energy, you've talked about multiple times prior to having this class, and any other science class that you have. It doesn't matter what science class, the conservation of energy is going to be important. Energy is neither created nor destroyed. Oops. Only, and here's the key part, transformed from one kind to another kind of energy. Here we go. So energy is neither created nor destroyed. It only is transformed from one kind of energy to another kind of energy. All right, it changes from this energy to that energy. And let's go ahead and look at an example. An example of this would be electrical to light, because you have your lamp on, to, and then that lamp gets hot, to heat energy. Right? Energy transformation is occurring from one form to another. Okay, the next one, conservation of mass. Well, that's super important in chemistry, like super important. Conservation of mass, also, we get E equals mc squared from this, okay? E equals mc squared. I know you've seen it, I know you've heard it, but E stands for energy, M, you already know, stands for mass. The letter C stands for the speed of light, and then you square it. So there's actually a math equation for this. So the conservation of mass is neither created nor destroyed, only transformed. And so we have an example right here as well. It says, for an example, if I have 116 grams of mercury 2 oxide and it's heated it makes 100 grams of mercury and blank grams of oxygen. So if I start off with this number, and I know it's simple math, but this is going to be super important for us later on. So this is like the beginning step of it. So if I start off with 116 grams, something happens, right? This is equal to this reaction that's occurring. Because when I get this and I heat it up, it's going to equal 100 grams of mercury, and the and is going to be a plus sign, and blank grams of oxygen. How many grams? Well, I understand this is fairly simple, and hopefully you're like, oh, it equals 16, which is correct. But the conservation of energy is whatever you start off with, you end up with the same amount. Okay? I'm sorry, the conservation of mass is what I meant to say. Whatever you start off with, you end up with the same amount. Alrighty? You can't create or destroy mass. Let's keep going. We're almost done. Classification of matter. So now this unit is all about matter, okay? But one way to, with matter, one way that we do is, one thing that we do in chemistry class is like we like to separate and categorize it. Okay, so all matter can be grouped into one of two groups. So all matter, every type of matter that's out there, it can either be what we call a pure substance, or it could be a mixture. Okay? A pure substance or a mixture. Now, let's go ahead and break those apart. Here's my pure substance and here's my mixture. So that's what we're talking about now. A pure substance. There are two types of pure substances. A pure substance, and you know what? I think they should have put that word here. Pure substance. And a pure substance could be either an element or what we call a compound. A mixture is either going to be heterogeneous or it's going to be homogeneous. Okay, so let's keep looking at this part. Here, elements. Elements, you know, elements are going to be on the periodic table, and they are the smallest form of matter. Okay? The smallest form of matter. Next one says here, for an example, when you're looking at elements or you're looking at a chemical reaction or something going on, how do I know that that's an element? For an example, we've got CO or CO. Which one of those would be an element? This would not be an element. That would be a compound. This is an element right here. Because the first letter is always going to be capitalized. If there is a second letter, it's going to be a lowercase. That's how I know it's an element. For an example, FE or FE. Well, it's not that one. It's going to be this FE, right? Because it's capital and then lowercase. Then it says here, this next part is super important in chemistry. We've got some elements that are really special. And these special elements from the periodic table, we call them diatomics. Okay, so hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are all what we call diatomics. And a diatomic element are elements that are always found in twos. They're always found in twos. They come paired together. So if you're looking for an oxygen and you find an oxygen atom, it actually has another oxygen atom attached to him, and they're always together in twos. Okay, they're called what we call diatomic. Okay, let me give you a little hint though, because I like to try to give you my hints. I'm gonna put right here, remember the 777. Okay, so my 777 rule is going to help me when it comes to the diatomics, and we're going to talk about this when we get to see each other come Tuesday. Okay, our diatomics, and I will make myself a note to go over diatomics on our teams meeting that we're going to have. Okay, I would rather make sure I tell you versus just telling you on the video. Okay, they're that important. Now we have other things that we have, and we call those compounds. So I'm going to just put a little line to break it here. I'll put a little line just to kind of break that up. So compounds. Compounds are two or more substances not chemically combined and you can physically separate. Okay, so a mixture is two or more substances that are together, but they're not chemically combined like a compound. Oh my goodness, I just see what I'm doing right now. I am making a big mistake. I wish I had you here with me so you can tell me, Miss Munson, that is not a compound. You're right, that's a mixture. I was giving you the definition of. I'm pretty bad when we have lecture in class. I'm always having to have whiteout with me for my mistakes. I just start writing. I get all excited. I don't know. A compound is two or more elements that are chemically combined. They are bonded together. Okay, example, H2O, NaCl. All right, H2O, it is chemically bonded together. NaCl are chemically bonded together. I'm so sorry, forgive me for that. Let me now draw my line. And let's go to the next one, which is a mixture. Okay, and a mixture is two or more substances that are not chemically combined and can be physically separated. Okay, you can physically separate them, and there's different types of techniques when you physically separate them. Now remember, over here we've said that mixtures are homogeneous or heterogeneous. Okay, homogeneous is going to look, I'm sorry, I meant to say heterogeneous, is going to look different throughout. A homogeneous, which are solutions, are going to look the same throughout. And just for my sake, I'm going to go ahead and separate the definition of mixtures and the definition of heterogeneous versus homogeneous. Just for me, that way I can have them all separated. Okay, so heterogeneous, what would be some examples? Pepperoni pizza, salad, Chex Mix, those are all good examples of heterogeneous. Homogeneous solutions would be like chocolate milk, Kool-Aid, Gatorade. Okay, we've got, those are different solutions. Salt water, vinegar, all of those are solutions, or they're homogeneous mixtures that are the same throughout. So let's go ahead and let's physically break this up so that way we can see it into a chart form. I like looking at it this way. First thing is that our topic for this unit is matter. That is what we're talking about. And all matter can be separated, we said earlier, into two groups, correct? So let's look at those two groups. One of them cannot be physically, and we're using the word physically because chemically you can, but when you do break it apart, then it's no longer the same thing. But this side cannot be physically separated. Oops. And this side can be physically separated. All right, make sure you're getting your notes filled in. So in this case then, this side of the matter, or what type of matter is going to go in here, is what we call a pure substance. And on this side, our matter is going to be what we call mixtures. Okay? Now, we've got different kinds of pure substances, and we got different kinds of mixture. On this side, one kind we have is elements. Leave the space down here, we're going to do something. And the other type of pure substance are compounds. Mixtures, there are two types of mixtures. We have heterogeneous, E-O-U-S, and we have homogeneous. There we go. Now, and here's where we're going to get those other parts of our notes. Remember I asked you, hey, do you have scissors at home? And y'all told me yes. And here's where we're going to actually put a physical picture as our examples down here. So when we cut them out, get ready to glue them. I know you have glue sticks. 1, 2, and when you submit your notes, these should have been cut out and they should have been glued to your notes. There we go. Now, I don't have glue here. I gave y'all all of my glue, but I got tape. So let's go ahead and let's get started. I'm going to start off with elements since we're over here. That's like the easiest one, right? It's going to look like this. Elements. It's going to be the same throughout. All right? And not only that, but they're going to look the same throughout, but there's only one kind because an element is a single element by itself. So it's all going to look the same. Now, compounds are going to be two elements or more that are chemically bonded together. So if I had to look at those, and they're always going to be the same no matter where, this would be it, a compound. So let's go ahead and glue that one in. Next one is heterogeneous. And heterogeneous, we said, it's going to look different throughout. It's going to be all jumbled up and different. Look at this one. This one has 1, 2, 3, 4 of those, 1 of those, and 3 of those. It's all different. And a homogeneous is going to be a mixture, but it's going to look the same. Look at this. 1, 2, 3, 4. 1, 2, 3, 4. These two, yellow, green, yellow, well, my putting them in color. Yellow, green, yellow, green, yellow, green, yellow, green. Right? And all of those 4 browns, they're all the same. It's the same throughout. And then heterogeneous is all mixed up. So here we go. Here we go. And homogeneous. All right. So we're not done yet with cutting and gluing. Now down here, they want examples, and here are your examples. Cut those out, and part of your grade is to cut them and glue them. Yes, it is part of your grade, so get that part done. It's very easy. And these are examples. Alright, let me get this trash out of the way so you can see what I'm doing. And that. I'm going to start again at my elements again. On my elements, it's going to be the same throughout. Look, there's 2 things there. That's an element and that's an element. How do I know the C and the O are both elements? Because they're both capitalized. So that can't be it. Those are words. They're not even elements. Those are words, but look, they're actually elements. Oxygen, hydrogen, helium, carbon. Those are elements. But those are compounds that are bonded together chemically that are going to be the same no matter what. Now I've got heterogeneous. Heterogeneous is going to look all mixed up, all jumbled up. For an example, if I have a pepperoni pizza, every single slice is not going to have like 4 pepperonis exactly identical. No, one might have 5 pepperonis and the other slice might have 2. So it's not the same throughout. And all of those are considered solutions, including brass. So for some of you are like, wait a minute, I thought brass is a metal. Yes, it is a metal, but it's considered to be a solution. There we go. There's always exceptions to the rule in chemistry. That's one thing that makes it hard for me. All these exceptions. Here we go. Let's go ahead and glue those in. And the next one. And then the last one, which is our homogeneous mixture, which is the same throughout. There we go. Okay, let me move that out the way. Now let's turn the page. We're almost done. This is an old set of notes, so my notes on this back side are going to look different than yours. I'm sorry. My notes may look a little different than your notes. I have the pictures here. Now these are the last ones, so let's get these cut out. And all of these 7 are examples of physical separation techniques. Okay, physical separation techniques. And if you were in class with me, we would be doing the chromatography at your desk right now, but unfortunately we're just going to settle for a picture. There we go. Now, there are more than 7 types of separation techniques. These are the 7 most common ones that are used in labs. Okay? Not just chemistry labs, but, you know, out in the work field, whenever, you know, they're testing, doing tests, or they're trying to come up with a new medication or something, they use these separation techniques. Alrighty, I'm almost done. Get all of yours cut out as well and get ready to glue them in. Now, I might be wrong, but I think your notes kind of look like this, where there's like another line. Let me see, there's like one line here, one line here, one line here, and one line there. So I think yours kind of look like that. And what we were going to need to do is we are going to need to, it doesn't matter, but on the first row, let's go ahead and tape in 5 of them. Skip the second row and let's go to the third row. You've got 2 more to tape in. Believe me, there's a lot more separation techniques. So what we're going to do is we're going to tape those in or glue them. And then over here in the spaces on the side, we're going to write what they are and how they're used, okay? So let's go ahead and get that done. Glue them in, okay? Again, this is part of your notes expectations for your grade, is that they are glued in. I don't care how you do yours. You can glue yours in a different order as long as you have the correct information to go along with them. There we go. And there we go. And then we've got 2 more on the side over here. Whichever 2 that you have, it doesn't matter. There we go. So get yours glued in. I'll get mine glued in or taped in. Let's go ahead and get started. We've got 7 different techniques. All of them are super important. Okay? But let's go ahead and fill them in. This one over here, wherever you stuck this one at, it doesn't matter, but this one is filtration. Okay, I left space because I'm going to write some stuff in there. The next one over here is going to be magnetic separation. All right, the next one over here